Very warm welcome to you all to this edition of X Live. My name's David Cunningham. I'm at XBlue HQ here in Saint-Germain, just west of Paris. I'll be joined shortly by a colleague from our sonar systems division down in the south of France in La Ciotat. In case none of you have seen an X Live previously, the format will be around about a 15-minute presentation, followed by questions and answers. So please don't hesitate to post your questions through the course of the presentation, and we will answer them all. This is a big subject. We don't propose to delve very deep into the topic in the 15 minutes we've got, in the half an hour sort of presentation we've got. So if you want to follow up with further in-depth questions, then please do so afterwards. We'll post a recording of this on our website, and it will be on YouTube, on our YouTube channel, so you'll be able to see it later or share it with colleagues. That's it. Right. Let's get into the story and introduce Guillaume Jouve, who's
hello, David,
with our team down in La Ciotat. And so, Guillaume, maybe you can start by just giving us a quick overview, a quick introduction on the history, the technology, and maybe the product range as well of the Echo series.
Oh, yes, of course. So Echo series provides the best high-resolution sub-bottom profilers. So this comes from 30 years of field-proven technology and expertise in designing transducers. So basically, Echoes are chirp system. So each system is an emitter and a receiver. The Echo series ensure the best signal quality thanks to a unique flat spectrum for characterizing, let's say, the structure of the first 200 meters of sediments. So Echoes ranges from the 3500s, the 5000, and the 10,000. So depending on the water depths you need to work and also the resolution you want to obtain. So we have a full range from low, deep water systems that can be Hell mounted to higher frequency portable plus AUV, RV mountable solutions.
Okay, that's good. That's a 10-second introduction to the Echo series. In a nutshell, the range includes systems for deep water, permanent installations on research vessels, the 3500, which is available in a range of different sizes, all the way to the 10,000, which is the really small, portable, higher frequency system for let's say, temporary mobile installations. And all adopting the same transducer technology, which you mentioned, the flat spectrum of the signal. Maybe you can just dig a little bit into that and explain what that means, Guillaume.
Yeah, so the flat spectrum is a key characteristic of the Echo series and leads to better quality data. So with our transducer technology and advanced signal processing, we have a perfect control of the bandwidth of our transducers. So as can be seen on the left side of the screen, we are perfectly power efficient in the announced bandwidth of the Echo 10,000. So this means that we have the best signal quality on the seismic data, meaning also that we have the best signal to noise ratio and we don't observe any false sediment layers. It's like we design hi-fi for geophysics, producing the very best data.
Okay, so the flat spectrum, the control of that signal is at the heart of the data quality across the full range, bringing various benefits to the user, to the operator. But basically, it's about better data. So let's say better records. But beyond that, is there any other feature? What about object detection, Guillaume? Is that feasible with these chirp systems?
Oh, yes. Yes, we can. So because of the wide aperture of the Echoes, it's certainly possible. The beam aperture is about 15-20 degrees and allows to obtain multiple returns from a single object during the survey. So this generates parabolas, the top of which is at the location of the object. So here you can see on the screen, you can follow the exact position of the pipeline. So the object detection capability is a distinct advantage over narrow beam aperture systems such as parametric, for example.
Okay, so with the chirp system, you've got this wider beam aperture giving you the opportunity to detect objects. You have multiple signals across along a line, so you can track pipes, or you can find pipes and cables and so on.
Yeah, right.
So just coming back then to the data quality topic, we were discussing earlier about this flat spectrum delivering, the best quality data. So in terms of the value of that, why is that? What real value does that have for the user? It's not just pretty pictures.
Yes, right. So I try to make this simple. So better data allows rapid, close to real-time post-processing. So quality data means also horizontal continuity through the survey. So it allows automatic detection of the sediment layers. So for example, using Delft here, you can see on the top of the screen, the seismic reflection profile. So you double click on a layer and you follow all the layer automatically, and you can generate with all your seismic profile isopack, so digital terrain model of all the layers you detected, and you can extract very rapidly with Delft, for example, volume of sediments or the thickness of some deposits, and this can be done very rapidly. So fast processing with minimal cleaning means that analysis of the data can start sooner, and obviously reporting is completed sooner also.
Okay, so the real value in the higher quality data is the opportunity to use automated processing techniques, or you have very much faster data cleaning or processing, which gets you to the end report much quicker. Which,
yes, right.
I can see that being of interest, let's say, as more and more data is generated with unmanned systems, for example, generating big data sets with no people nearby to clean them. You don't want to generate a workload later. So this real-time quality of data is really valuable in that context.
Right.
Okay, that's good. So now let's just get a little bit more operational, Guillaume. Maybe you can give us an overview of the installation options across the range. And I know that it's a big topic, so we can't dig too deeply into it.
Yes. So obviously installation options depends on the model you have. So as mentioned previously, we have hull-mounted options for permanent installation, and we have AUV deployable system, and of course USV deployment on rigs, for example, is also possible. But let's have a look at the ECOS 10,000. So for example, which is the small, highly portable and well suited to temporary mounted option. For example, and on the screen, we can see a small boat with the ECOS 10,000 antenna, put it on the pole. And then on board, you need a laptop, the topside unit, and the GNSS. And you can observe in real time the acquisition with the Delft seismic software.
Okay, yeah, so the simplicity of the pole mount option with a system such as the ECOS 10,000 is obviously a portable system, and the options obviously going all the way up to the large ECOS 3500 7 transducer system permanently mounted on a significant size research vessel, as well as
it's
AUV.
very rapid. So in about 1 hour, you can start your geophysical survey.
With the ECOS 10,000, yeah, good.
With the ECOS 10,000, yes.
And then you mentioned the AUV installation with the ECOS 5,000.
Yes.
Yeah.
Okay. Yeah.
Okay, that's good. So now, staying on the theme of the ECOS 10,000, we've seen the simple installation, the pole mount on a vessel opportunity. Have you got some data to show us of the ECOS 10,000, which has got some interesting features, I think?
Yes, we have an example that we can show on the seismic profile. For example, this comes from a survey we did in Scotland and within an archaeological project. And we can see on this profile several interesting features. So we have gaseous fluids, We have the fine clay-rich sedimentation, and we also have on top of it small parabolas. And these correspond to isolated high reflectivity objects. And actually, we cored these sediments. And we found a lot of cobbles and pebbles. And each of them correspond to one parabola that is observable in the seismic profile.
Okay, that's great. So this is the core with the pebble, round about 10 centimeter diameter, I think. Guillaume, is that right?
Yes, right. It's about 10 centimeters. Yes, right.
Yeah. And I don't know if for our viewers, if that is very easy to see in the presentation. But if not, then please contact afterwards, and we can show you a bit more in a bit more better resolution, perhaps. That's sort of the end of our presentation, Guillaume, I think, isn't it? We're ready for some questions. I think in summary, we've got this full range of sub-bottom profilers, which are all field proven and in operation, unique chirp quality data, delivering really, really fast results with the Delph processing solution software.
Yes.
So, questions, Guillaume? Are you ready for questions?
Yes, I'm ready.
Right, here we go. We've got some here. We've got one. Our very first question is, what's the difference between reflection seismic and sub-bottom profilers, and where does the Echo series fit into that?
Okay, so the reflection seismic is a generic term. So sub-bottom profilers represent the high frequency part of the reflection seismic. So echoes overlap from 1.7 kilohertz to 15 kilohertz. And echoes can be used together with reflection seismic for better resolution in the first tens of meters. And what we can say, finally, that sub-bottom profilers reduce human risk, contrary to reflection seismic, lower frequency system.
Okay, hope that's clear. Another question. What are the benefits in developing a pole-mounted sub-bottom profiler, like the Echos 10,000?
We have a lot of advantages, like positioning, for example. So if you have motion and weather, you have bad weather, so you have a continuity in the signal, and also you have a Z reference that is constrained using the pole-mounted version. Also, no winch is required and can be used for side scan sonar or mag instead, for example. What is also an advantage is working in shallow water and in marine traffic areas, for example, also. And we can work very close to structures like harbors or wind farm.
Okay, so there's a number of operational advantages of not towing things, and you've got better positioning.
And for example, with if I can add just something with the 10,000, we can work until 1 meter of water depth.
Okay, yeah. So you can get into much shallower water,
super shallow environments,
close to structures, and you've got an advantage with the let's say the heave compensation and the positioning of the data.
Right.
Because you don't have the uncertainty of the towfish positioning. Okay, that's good. We've got one here about the Echos 3500.
Yes.
And so Echo's models come with numbers 3500, 10,000, and letters T1, T3.
Yes, exactly.
What's the? Can you decode that for us, please?
Yes. So, for example, the 3500's T1 is 1 transducers. So you have a beam aperture that is wider, and the T3. So you have a narrower beam aperture and the 7 transducers. So this means that you have different transducers. It means that you have different penetration that is associated with that. Okay.
Okay, so the 3500, the 10,000, the 5,000 is the nominal, is the center frequency of the.
So 3500 is the central frequency, of the bandwidth, and it's also the bandwidth.
Yeah.
So for example, let's say an example with the 10,000, for example. So the 10,000 is the central frequency, and it's also the bandwidth. So it ranges from 5 kilohertz to 15 kilohertz.
Okay. Yeah, that's clear. Okay, thanks. Now, you answered this question earlier, but maybe it's helpful to repeat it. How shallow can you get with these systems? How shallow?
For this 10,000 or?
For the systems, maybe, yeah, the 10,000.
For all the systems?
Yeah.
Or for 10,000, so for the 10,000, we know that we have very good data from 1 meter to 150 meters of water depth, and we can penetrate in a few, let's say, 10, 20 meters to sometime in clay environments. Recently, we go deep in 40 meters of sediments in 5 clay-rich sediments.
Mm-hmm. Okay, that's the ECHOS 10,000. Okay.
Yeah. For example, for the 3500s, so we can work in full ocean depth. So the big hull-mounted system, for example, we can work in full ocean depth.
Mm-hmm. Okay. Hopefully that answered the question. Here's another one. You'll like this one. Can ECHOS replace a single beam echo sounder?
ECHOS replace a single beam echo sounder?
Yeah.
Yes, they can replace. Yes, we have natural chirp systems, so it do not interfere with them. We can work also with multi-beam echo sounder. So yes.
But it can be used to, will it measure the depth of the water? Can it be used as an echo sounder?
Oh, yes. So with depth, we can also obtain the water depths just rapidly. Yes, it replaces it. Yes.
It's not what it's designed to do, but it has some capacity in that area. Yeah.
Yeah.
So in the ECHOS 10,000 example data, what's the maximum signal penetration and vertical resolution?
So the maximum penetration, like I said, it's like we perform.
This is in the. This I think is in the image that we showed, Guillaume.
For the last big profile, for example?
The picture that we showed with the pebbles in it, for example.
Oh, it was a penetration of about 10 meters.
Okay.
10 meters of penetration.
Yeah.
For, if I remember well, in Scotland, it was about 10 meters of penetration.
Okay. Yeah. And what was the water depth there?
It was 25 meters of water depth.
And so then the subsequent, well, the associated question about that was, what was the vertical resolution?
Oh, yes, sorry, I forgot that. So the vertical resolution is 8 centimeters, but 7.5 actually, that's the theoretical resolution.
Okay.
And we know, because we have different examples with coring system, that we can observe this resolution actually when we compare with sediment cores.
Mm-hmm. Okay, that's good. So now we've got another one here. Where is my question? How fast is the bottom tracking option? Problem in the past with this being very time consuming, and also auto reflector picking not really reliable in standalone mode.
Okay, so it's automatic with depth. So through the survey, you can have an information about the bottom and the depth of the bottom automatically. So it's in real time with the Dell seismic software.
Mm. Okay.
And obviously, you can fine-tune this information in post-processing rapidly after the survey with Delph also. But you have your information in real time. Okay.
We maybe need to dig a little bit deeper into the answer for that question. There may be a further discussion needed, perhaps.
Okay.
So on another topic, when are fewer or more transducers needed? And he touched on this a bit earlier, but maybe you can just explain again.
Yeah, for example, in some environments, we have a few tens of meters of compacted sand to see below. And if you have more transducer, you can have more power in the beam, so you can more penetrate and see below some very hard sediment. So the more you have transducers, the more you can penetrate in the sediment.
Okay. There's another quick one about the ECOS 10,000. What penetration subsurface depth does the ECOS 10,000 offer? And is penetration depth dependent on the water column?
So the maximum penetration we get with the 10,000 is about 40 meters, and sometimes 45 with the 10,000. And we were at about 50 meters of water depth. We know for sure that we can get such good data, and the resolution never change until 150 meters of water depth. But if we tried like close to 200, it was also good, but we don't know. Maybe we can go with more water depth. We don't know that, but apparently good data until 150, 200.
Okay, that's helpful. We've got one here which is about the acquisition software, and I think we're going to take this as a suggestion for improvement of our product. Why does the acquisition software not show heave corrected data in real time? Basically saying this could be this would be a useful QC requirement. Especially where no post-processing is available on board.
Yeah, that's a good comment. Yes, so I will have to ask to Philippe Alain could have an answer for that for sure. And maybe we can just take the information and the name of the contact, and we will contact the person later for that.
Yeah, for sure. I think it's if it's not on our roadmap, then we'll find out where it needs to be on that roadmap.
Yes, sure. Yeah, okay. We'll discuss this point here.
So there's a point here about pricing. These systems are significantly more expensive than other systems. Can you say again what the main difference and advantages of this system versus others?
So
I'm not sure if that's true, if they're significantly more expensive.
No,
I don't have
no,
that.
No, it's not significantly more expensive. It's very close to other systems, but we offer a lot of more advantages. And one of these advantages is like we can also observe and characterize the sediment. So each environment, we have a solution for your environment. So a UV portable solution, hull mounted, and we can work it from 1 meter to full ocean depth. And what is very efficient with our technology is that we always obtain an information about the sediment layer, the buried objects. So we have full advantage for a price that is quite the same as others.
Yeah, sure. I think the flexibility, or at least the range of different capabilities of a system like the 10,000, for example, over and above, let's say, a parametric system that people might be, more used to using these days is quite distinct, I think, in terms of the object detection, but also the penetration and the data quality.
Yeah.
So this coming back to this question, what is the maximum water depth the ECOS 10,000 has been tested in, and what is the signal penetration and vertical resolution at that depth? So we're looking for the maximum water depth and the maximum penetration and an understanding of the resolution in that test.
Okay, that's a very specific question. So if I can remember well, so we worked at 150 meters of water depth, and we penetrated like 15 meters deep in the sediment. Mm-hmm. And the resolution is always the same. So it's about 8 centimeters of resolution for the system.
Okay, that's great. That's very clear. Moving on. How can we relate multi-beam or single beam with this discussion? I'm not sure what the.
So they don't need to be synchronized. For example, let's say we take the 10,000, for example. So we emitted in our bandwidth So it's a very lower frequency than multi-beam echo sounder. For example, that ranges from, let's say, 150 to 50 kilohertz to 600 kilohertz. So it's not the same bandwidth. So everybody is listening his own signal, and we can work together, and we can obtain and merge all of these data with the Delft seismic software and Delft sonar also. That so
yeah,
this is we worked very recently with two systems, so that's not a problem.
Okay, I'm not. Yeah, hopefully that answered the question. I'm not entirely sure if that was the point of the question, but please, if that wasn't the answer you're after, then
I'm sorry.
Let us know. Let us know, and we'll have another go. So there's another question here. Some other sub-bottom profilers are using parametric technology. How do Echo's series compare? So we've done a little bit of that, but maybe you can just give another quick overview, 10 seconds on that topic.
Yeah, so this we use natural chirp system. So again, it doesn't interfere with single beam or multi-beam echo sounder. So we have a wider and a better aperture that can detect the geology. So for example, the generate parabolas, and with parametric, it's very difficult to obtain. That would means that the boat should go very slowly. There is no waves because they have very narrow beam technology. So with this technology, we can observe a lot of features and signal continuity without all the motion possible on the field. And also we have better imaging quality. So it's easier, faster data interpretation, very more rapid. We need a lower power equipment and a smaller topside amplifiers.
Okay, that was it. 1, 2, 3, 4, 5, 6. 10-second story. Thanks, Guillaume. Right, now we're going to move to the Echoes 3500. We're going full ocean depth. So this is a question about what's the optimal penetration in sandy environment, say in the tropical conditions with the effects of thermoclines. So full ocean depths and Echoes 3500. Yeah.
Okay, so it depends on the transducer. So if we, let's say, so we want the 3 or the 7 transducers. So if we take the 3 transducers, we can see below several tens of meters of sand, let's say 20 meters of sand, for example, using the T3. And I'm not sure that the thermocline will affect a lot the signal. I'm not sure we have any effect of that. So if the person that asked this question had some trouble to see anything in the sediment because there is a strong thermocline in the water column, we can discuss about this point. But I think there is no problem with that, with our system.
And what about the 7 transducer system? Have you got some ideas of that one, Guillaume?
Yes, with the 7 transducers. So as I said, we can work in full ocean depths, and we have a lot of good data with the iPhone, for example, that is equipped with the high-mounted version of the Echoes 3500s with 7 transducers, and we have so many publications using these systems, technology of these systems, and so we know that we can penetrate of several tens to hundreds of meters in every kind of environment with these systems.
Okay, so you're talking what, several hundred meters with a 7 transducer system?
Yes, deep in the sediment, but we can work in several thousand of meters of water depth.
I understand. Yeah. We're talking about full ocean depth with that question.
Yeah, full ocean depth. Yeah.
Hopefully that answers the question. It's one of these things like how long is a piece of string, isn't it? I mean, it's very difficult to put a firm answer on it, but the answer with 7 transducers, full ocean depth, sandy environment, 200 meters. What are we talking? Several hundred meters when you.
I'm sorry, it cut it rapidly at the end of your question.
Okay, so with a 7 transducer array, The full ocean depth. How many hundreds of meters penetration can we have we observed?
We observed about 200 meters of penetration.
Okay. Okay.
Yeah, several times and 150 meters of penetration.
Let's move on a little bit from that, because it's a sort of never-ending story about, what if, and it's very hard to know. You can't put a precise answer on any of it, really. But here's one you can put a precise answer on. Does the system record the transmit signal spectrum for signal deconvolution?
Yeah. So what is the question exactly?
Does the system record the transmit signal spectrum for signal deconvolution?
Yes.
Yes.
Yes. They record everything. They record everything in XTF, but we can export in SegWi also. So all the transmitted and received signal and the correlation, so the chirp processes, everything is recorded. So we can see also the correlation, the Dirac, everything in the process is recorded with Delft Seismic. Okay.
Great. There's plenty more questions, Guillaume.
Okay.
Is Echoes compatible with recording systems other than Delft?
Yes, this is compatible, yes, with all other software, yeah.
Okay, yeah, so, yeah, I think basically XBlue's approach is to be as open as possible and to be compatible with industry standard formats and so on, and third-party software or systems as much as much as we can. So anyone that wants to,
if you, for example, just if I can add just something, if you buy the system, for example, any Echoes you buy, so the Delft Seismic software comes with it, so it's linked.
Is that
so you don't have
to
buy
software?
A software. It's in the package.
Is that the acquisition software or also the processing software?
Yes, everything.
The both. Acquisition and the processing. Okay.
Yes, and the interpretation. Yeah.
Okay, good. Right, more questions. Where have we got to? We've covered this, but maybe we'll say it again. What is the minimum depth into which Echoes 10,000 can be used? And do you have some sample data?
Yes, so we have data until 1 meter of water depth, but we never tried to go in shallower environments because we didn't want to block the system. But we know that we worked with some window that can protect it, so we could use. But we know that yes, minimum 1 meter for sure. We have good data.
So whoever asked the question, please drop us a line afterwards, and we'll we can show you the data and carry on the conversation. But yeah, into 1 meter, we've gone into 1 meter of water, and we could go further in theory.
Yeah.
So here's another one about Echoes 10,000. How does Echoes 10,000 work in the sand, in a sand predominant area? For example, the clayey sand, silty sand area. In the 10,000 Echoes example data that we showed, what's the maximum signal penetration in such an area?
Environment. Yeah. So it depends on the sand type. Yes. So from few meters to 20 meters in core sediment. So the more is compacted sand, the more it's difficult to penetrate. But sometimes if it's core sediments and we have a good penetration because of the porosity, we can reach at about 20 meters of penetration. And sometimes it's very, very compact and it's more difficult to go deeper than few meters, let's say maximum 10 meters.
That's good. It's a difficult question to answer, isn't it? Because it's so subjective.
Yeah, because it depends on the sand. It was demonstrated in the literature, so it depends on the type.
sure. So we've got another one here now, which is another again on maybe Echos 10,000 specific. Have you used these systems? Have they been tested in continental waters, such as rivers and lakes? And do we have to pay attention for something specific in continental waters? It's I think rivers and lakes.
Oh yeah, so we did several collaborations with university in France, in Belgium, in Germany, using the Echos 10,000 in lakes, so in different type of lakes. So we had crater lakes, mar lakes, so we have alpine lakes, and this is very interesting because depending on the sedimentation that is changing a lot in this kind of environment. So we can have very fine sedimentation, clay, silty sedimentation, and we can have also like mass transport deposit, like during earthquakes or after earthquakes or extreme runoff precipitation. So we have a lot of different acoustic impedance of the layers. So we have a lot of good data and information for characterizing this kind of environments. So recently, we had very good data that we presented during several conferences, international conferences, and that can be found on our website and all this reference. So I can provide you with a lot of data if you want.
That's great. And is there anything specific to consider when operating in, let's say, fresh water? Guillaume, is there any particular considerations for inland water surveys?
No, because it's not, as we said, it's a small system. It's easy to use. So generally on lakes, people have small vessel. So we put a pole on a sign, and usually we don't have a lot of bad weather or big waves. So it's a good environment to use the Echos 10,000. It's nothing very specific should be think about.
No, okay.
No,
just take it on. Yeah.
Yeah.
Okay, good. So another one about Echos 10,000. Okay, this is another good maybe future development. Can I use the Echos 10,000 to be in a towed option to reduce the larger water column? So can we deploy the Echos 10,000 in a tow body?
Yes, that's a good idea. Actually, we did that 1 year ago. So you can use a small cataract, for example, and it's a little bit, so you can track it here. And that's a good option also, and it works very well. So yes, we can use that. You have to think to an interface that we can also design on your own small tow or cataract. I don't know the things you are using, but yes.
I think the point of the question is to tow it underwater to reduce the water column.
To reduce the water column.
Yes. Can it be towed underwater?
Yeah. So for the 10,000, we can put the system until 7 meters below the surface. But for the 5,000, sorry, so we can tow until very close to the surface. And this is an AUV kit also, so you can work until thousands of meters of water depth. So yes, it's possible with the 5,000. That is a good penetration resolution.
Yeah. So for the 10,000, for this unit here, it's only rated to 7 meters below the water. So not really, it's not going to give you a huge advantage to deploy it on a towed system. But the Echos 5,000
would be the good solution for you. Yeah.
Okay. So here's one. We have an Echos 3500 T7. Is there an option for us? Is there an option to use different transducers numbers, say 1 or 3 instead of 7, always, for operation in shallow water? Would there be an advantage to this? So they've got the 7 transducer array.
Yes,
Can
you got
they
it. Yeah.
just use 1 transducer or 3 transducers within the array? And when would, when might that bring some interesting advantages?
Yeah, so there are several solutions. So maybe they keep the 7 transducer and they do not remove any transducers, and we can just electronically just use 1 or 3 or 5 transducers. So to generate the beam, we cannot do anything we want. So we cannot use, for example, 2 or 4 because we need to generate the beam. So that's the first point. And also, what could be the advantage? It's to use less power. If you go in shallow water environment, you don't need a lot of power because you go in shallow water environment. So you should not be intoxicate too much the water column. And yes, but I mean you have
But so the ecosystem is the 7 transducer system can be operated with 1 transducer alone, or 3, or 5, or the full 7.
Yes, I should ask some details to some of my colleagues to be sure that we can do that without any problem. But yes, I think we can design that electronically. We can do something with Delph. Yeah, I should ask to be sure.
Okay, so we need to dig a little bit more to get the
confirmed
answer on that one.
Yeah, to confirm the answer. Yes, it's important.
Let's follow up after this event. Please drop us a line.
Yeah.
Or maybe we have the details of the questionnaire. What about? Okay, here's one. This is what about coarse sediment penetration? Big question. I don't know.
Yeah, so by coarse sediment, I mean that it should correspond to coarse sand or gravel on rocks. So sometimes, okay, so the more it's fine, like clay or silt, the more it's good for good penetration. So in coarse environments, it's more difficult to penetrate. But if we have big power, like the 3500 T3, we can penetrate of several tens of meters without any problem. We have a lot of example of that.
Okay.
We even detected pipelines in rocky environments. So yes, we can be very efficient in very hard and coarse sediment.
Okay. So that, I think, is again, it's another one maybe for a conversation to carry on. So we can maybe show some data examples. Guillaume can show you some real survey data and maybe add a bit more to the answer than we're able to with in this context. Another question here about Delph acquisition. Is Delph acquisition and Delph interpretation integrated in a single software in the future? So today they're 2 separate modules, the acquisition and the post-processing. Is there a plan to combine the 2?
That's a good question / comment. So I have to note this comment and to discuss with my colleague. But yeah, why not? I don't know. I don't have the answer. Okay. I have to discuss with Philippe.
So we can come back to you with the answer on that, having consulted with
yes.
The
just
Delph,
don't hesitate to send us an email and we discuss about that.
So here we go. This is one about the AUV ROV option. So the Echos 5000. What is the weight and dimensions of the total system for the Echos 5000? Have you got any of those numbers in your head, Guillaume?
Unfortunately, I don't want to. I'm sorry. I should answer probably this question, but if you let me a few seconds, I could check on my.
Have you got it right there? If you have, otherwise we can come back with the answer later.
Yeah, I can come back with the answer. I'm sorry to don't have the answer, but you can send us an email also with that. So let my contact to the person that asked this question, and I will just answer rapidly.
Yeah. Okay, we'll leave it like that for that one. So we've got another one about shallow water. Everybody wants to go very shallow here. In very shallow water, 1 to 2 meters, does the acquisition software for Echoes 10,000 do the basic filtering of multiples, or is it necessary to wait in the post-processing stage to do that filtering?
For the multiples, yeah, for the multiples, we have to wait for the post-processing. Okay. Yeah.
So that's not dealt with in the real-time environment.
No, in real time, we have to clean that in post-processing. But you do see and characterize the sediment you want to see in real time. But actually, the multiple with depths, you will see that on your profile.
Sure. Yeah, but that's obviously quickly removed in the post-processing stage.
Yeah, you can post-process that. Yeah.
We've got a couple more here. For the towed option, what would be the cable length limitation?
The cable length limitation. That's also a good question. I'm sorry, I didn't use this system a lot, not recently. So I don't know. I will note this question also.
Okay, we'll hold that one and come back to you.
Yeah, yeah.
Here's an easier one. Can we try the Echoes 10,000 before buying?
Yes.
Yes.
Yes, we can. Yes, we can with demo and trials. Yeah, no problem with that. We'll be happy to do demos for you. Yeah.
So here's one about comparing an existing system. I think so. What system do you think would be comparable to the conventional hull-mounted pinger 4x4?
What is it, the frequency?
I don't know.
Is it configuration of this pinger?
I don't know. It's a conventional hull-mounted pinger 4x4. Is the question?
Yeah. So for the pinger, so we have different systems. So, but if I put this answer easy, that would be the 3500 would be the best.
Yeah. So the 3500 is
can work in you can have with several hundreds to thousands of meters of water depth, and you can penetrate of tens of meters deep in sediment. Yeah, so 3500 T3.
Yeah, okay. So the 3500 T3 sounds like the most is where you'd start looking, and you might.
Yeah, or T1. It depends on the sediment. Yeah, T1 could be also a good option.
Yeah. Good. What is the possibility of the ringing effect in water depth less than 5 meters for the Echoes 10,000?
Yeah, so this is a good question, but we do have data of parabolas and the ringing effect in about 5 to 10 meters in Scotland, actually, because these pebbles and cobbles, we saw that in very shallow environments. Mm-hmm. So yes, apparently between 5 and 10 meters, we have these parabolas generated also. So I should check in details to see at what time we do not see these parabolas to verify on the seismic profile. That's also a good question. So you have to go through the profile and check the water depths and see at what depth this stops. That's a good question. I have to check that.
Mm-hmm. Okay, good. So we've got one here now about training. Yeah, so can Xblue provide training and services for first-time users?
Yes, we provide trainings. So on-site setting to work and assistant on first jobs. Yes, we do that.
Okay, yeah. So I think well, maybe to extend the point, we've got we've got systems available for trials or for short loans.
Yes, we do have.
We can support. Guillaume will be more than happy to come and help and provide training and assistance in let's say an initial operation of the system.
Yes, and if all the person, yes, like geophysicists or anybody, engineers or anybody wants to come and see our laboratory, see how we works, and we can try that on our environment in these coastal environments. We can go on your own site and see if it's a good system for what you're trying to obtain. So yes, just discuss about what you need and we will find a solution.
That's great. Thanks, Guillaume. I think that's the end of our questions and answers. So thank you very much. Thank you very much for your questions. And thank you very much for your answers,
to everybody for attending this X Live.
Yeah. Thanks for joining us, Guillaume, and we'll catch up soon. Cheers.
Thank you, David. Bye-bye.
Okay, well, thank you very much, everybody, for your questions. That was excellent. Hope you found the webinar useful. As I said before, we needed to keep it at quite a high level because we weren't looking to get, with the time available, we weren't looking to get too deep in any particular aspect of the Echo series, the Delft software, and the general topic. But please, please, please contact us immediately if you've got more questions or you want to follow up on any other aspects of what we've talked about here today. That's it for this show, but we will be continuing. We'll be doing another one of these events later today, but later this month we'll be doing another X Live about our CPIX multi-beam sonar, particularly looking at fisheries applications with that webinar. So if that's interesting to you or any of your colleagues, please join us then. In the meantime, thank you for being with us, and we'll hope to see you again soon. Bye.